Tonight, we have a presentation by Bob, WB4APR. Bob joined us a few months back to talk a little bit APRS, give us some info on that. And he is now back to give us a presentation on energy choices for the amateur. Should be a rather interesting presentation, I think.
This talk is going to be all over the place, and I've apologized. I know my last talk to Vienna Wireless Society was supposed to be on APRS, and yet whenever I talk on APRS, I tend to work in all of my current interest in solar and electric cars and everything else. So a lot of what you think you're going to hear, a lot of you are going to say, oh gosh, he said that last time. And all of this material is in the book that I wrote for the ARRL called Energy Choices for the Radio Amateur. And then there was a one-page article on building your own microgrid in May of, I guess it was 2019. So anyway, there's 6 disruptive technologies in energy and power. And, you know, if we ignore them, we wouldn't even notice because, again, we just seem to have seamless power. Nothing's really changed, and yet everything has changed behind the front panel. First of all, power supplies these days are almost all universal power supplies, 100 to 240 volts AC. But the hidden gem is that they'll almost all of them will also work on 100 to 330 volts DC. And that's what ties everything in this talk together. Of course, we now have LED lighting everywhere, which saves 80% of our lighting budget for the house. Solar power is now cheaper than coal and gas and costs less than half the cost of the utility if you hook it up. And a lot of cars these days are hybrids, and every hybrid has a 50,000 watt generator that sits in your driveway, and you take it with you everywhere you go. And so that's an untapped resource. And electric vehicles are now better, faster, cleaner, quieter, safer, cheaper to buy, cheaper to operate, and cheaper to maintain than the average gas car with incentives. And of course, there's talk about, you know, whole house battery backup, think the Tesla Powerwall. And so this talk kind of ties it all together because all of these are high voltage DC, and they all can be pretty much integrated together. Energy is more than a hobby. It can save you money. My background, it was in 1965 or so, I rewound my first generator to be able to have field day power. And in 1970, my senior project at Georgia Tech was to build an electric car. And these are just some of my other energy projects. Of course, in 1990, I invented APRS and kind of didn't do much with energy for a while, but I'm kind of back into it now. So emergency power and energy is kind of the topic here, and mostly because I've always enjoyed field day, and not so much from the operating, but just hooking it all up and providing power. So if you want some serious portable power, think an electric vehicle. As I said before, every plug-in hybrid has a 50,000 watt generator in it. And the battery vehicles like the long range Model S from Tesla has an 85 kilowatt hour battery. That's 85 days, excuse me, that's 85 hours of continuous operation at the 1 kW level, which is the average American house draw. And on the left there is a picture of a typical 50 kW generator. And you realize now that comes in every hybrid. Again, electric cars are in 2 categories. There's the battery electric, which has no gasoline engine and has a very large battery. And then there's the plug-in hybrids that contain a gas engine for backup and enough battery to provide most of your daily electric mileage. For example, a Leaf, the #1 selling electric car in the world, has equivalent of 48 12-volt batteries worth of energy. That's a lot of energy you can use as a backup system. I wrote an article on this, and it was published in October CQ magazine on my latest toy, which is taking my Chevy Volt and kludging up the roof a little bit so that I have a flat surface area for some high capacity solar panels. And the trunk still opens, and it was a great little project. And the total impact on the car is just the 3 pieces of removable plywood, 2 across the sides and 1 across the back. And it only takes 4 screws to remove all that if I want to. I've said that again, every hybrid has a 50 kW generator. But here is where solar and electric vehicles are the perfect marriage, because all it takes is 12 solar panels and you basically have transportation for life. 12 solar panels can provide the average 40 miles. That's the American average travel every day forever, with no dependency on foreign oil, no going to the gas station, nothing. Just sit there in your driveway and collect that solar power and always have transportation. The reason I'm so emphatic about solar is I was so wrong most of my life, because as a ham radio operator, I thought of energy as something which starts with a huge battery in the basement, and then you use solar power to charge that battery, and that's a ham radio heaven. The problem was, no matter how I looked at it, it just was not cost effective in any way, shape, or form. And the reason is I was so wrong, and it's because I thought of batteries for storage. And what has totally revolutionized solar is you get rid of the batteries and you go grid tie, and use the grid as the place where you dump your excess energy during the day when you're way overproducing what you need, and then you have it available at night or in the winter as needed. And the beautiful thing about this is there's no cost for the batteries, there's no maintenance for the life of the system. The average American home draws about 1,200 watts. Now, here's the great ham radio solar paradox, and that is solar is a fantastic do-it-yourself thing. It's a solar panel. It's got 2 terminals. That's 30 volts at about 7, 8, or 9 amps. And there's just all kinds of things you can do with that. And everybody wants to go out and buy a solar panel, hook it up, and hook it up to a battery and go solar. The problem with that is that's great for 1 or 2 solar panels, but beyond that, where are you going to put that energy that you're generating? The beautiful thing is for about $75 or so, you can buy something that looks like a 12 volt to 60 hertz inverter, but it's a grid tie inverter, and so you can actually take. Oh, excuse me. So let me back up. The point of this slide is to say, so you have that solar panel and you bought it, and it sits there in the sunshine and it charges up the battery in your shack. And after the first day, it's fully charged and your solar panel is not doing anything. It's just a wasted investment because your battery is fully charged. And unless you're operating a contest and operating continuously, your battery is fully charged. And so again, your investment in solar is not doing anything. So at the end of this talk, you'll realize that if you have gone grid tie and you have a net meter, then not only the 1 or 2 days a year that you use that solar panel, the other 364 days of the year, you're backfeeding that energy into the grid and getting paid the full 15 cents a kilowatt hour for that power. So everything in my yard that has solar panels on it for temporary use also has a grid tie inverter to backfeed, just plugged into the outlet in the garage. This one's plugged into the outlet on the front porch, so that I'm getting full retail value for all of the solar produced, not just the day that I might use that particular asset. But again, you can't do any of this unless you have a grid tie account, and you can't do anything with grid tie without the full set of inspections, detections, permits, and so forth. So remember, I started this section by saying it's the great ham radio paradox, in that anybody can hook up solar, but you cannot get any retail value for that investment unless you have a place to dump it, and that's a grid tie. So it's a whole new world of power. On the left is a 9 amp power supply. You weighed 50 pounds, and so now power supplies that occupy 1/10 of the volume, 1/10 of the space, and are ubiquitous and are universal. And that brings up this high voltage DC topic, because the first thing that all these power supplies do in order to be universal is to immediately full wave rectify that incoming power, and then use that into a DC-DC switching power supply. Of course, since that plug can plug into 120 or 240, the output of that bridge rectifier is 336 volts DC. And so that's kind of the new universal DC distribution capability. Here's how I use that to advantage. Every year we do what's called the Golden Packet Event, to kind of make up for the lack of APRS at field day. We go out and do our own thing, and we try to communicate from Maine to Georgia. It doesn't show up here. Along the Appalachian Trail by getting 14 volunteers to go up and man a mountaintop and play APRS. Now, my particular position is at the top of this hill, which is in central Pennsylvania. It's a private park, although it's open full time, and so anybody can 24 hours a day enter at the bottom, climb up 80 feet of vertical ladders, and at the top you have a great observation point. The problem is that's 3,200 feet from the parking lot, and so how do I power my operations at the top of that for the 4 hours of the event? And the problem was the first time I did it, I said, oh, I'll use solar power. So I took solar power and a battery, and just barely made it because it rained and it was shady. And that's when I realized solar power is great for Armageddon and for backup, but it's not great for emergency on the spot right now when you don't know what the weather's going to be. So anyhow, what I ended up with was, it's called single wire earth return. And on the left here, you see the cigarette lighter adapter, which gives me 140 volts of, up to 140 watts of 120 volts AC. That goes into a little box here that has 2 capacitors and 2 diodes to give me the 330 volts of DC power. The set of clip leads clipped to ground rods at the car, and the binding post on the top of that box connects to one end of 3,200 feet of number 22 hookup wire, and at the top of the hill, a binding post and 2 receptacles. And into those receptacles, I can plug in almost any universal power supply and have hundreds of watts distributed over 3,200 feet with a package that will almost fit under the seat of the car. Oh, I should have shown this earlier. So this is what we're talking about, is tapping into the 12-volt system, going through a standard inverter, and then the diode doubler, and you got 300 volts DC on this hookup wire. And because you're operating at high voltage, you only need 1/10 of the wire ampacity, because again, wire loss is proportional to I squared. And so when you increase the voltage, you drastically reduce the wire size. This is kind of what it looks like. And there I am operating at the top, and you say, what does this have? Well, so this is just showing you a way of using emergency power. It's not legal in the United States to do single wire earth return tied to the grid, but of course this is independent of the grid. And of course I'm taking a risk of having 330 volts DC on a wire that's unprotected, but that's a risk I took for this demonstration. Anyway, so it's all a field day and emergency power. And so the first thing I did was added solar panels to the roof of my car and built a little solar trailer. And that is great for providing solar power unless it's a bad day and you don't have the sun available. So a lot of people have always dreamed of having this huge generator in their backyard. But remember that around here in Maryland, the typical power outage is about 4 hours a year, and that's less than $1's worth of electricity. And so when you invest $10,000 in a battery backup system or a 10 kW generator to provide $1 worth of electricity, I say there's a better way to do that. And usually it's to buy a can of gas and a $200 generator. So people ask when you have solar power, what do you do when the grid goes down? And you say, oh, it's exactly the same thing you do now. Solar is economical power. It's not necessarily emergency power, except in the long run. And so again, back to the hybrids have plenty of power. Now on the right is what I have in the back of my Prius, and it's just a little $100, 1200 watt inverter that's hooked to the 12-volt battery, because the 12-volt battery in the Prius is back in the trunk. And so that little inverter will power everything from my electric lawnmower, chainsaw, skill saw. I have not found a single tool that won't run. Oh, it'll even run a small air conditioner. I've enjoyed sitting in the sun in air conditioning powered from that inverter. Now, the ideal thing is to come up with a larger inverter that has a 200 to 300 volt DC input, like you can find if you're very lucky in some uninterruptible power systems. If you can find one that has that high voltage input, then you can draw up to 6,000 watts from a Prius, for example, on a continuous basis, because again, the gasoline generator is a 50 kW generator. It has plenty of capacity. It turns out the Chevy Volt, so every hybrid and every electric car has this huge DC to DC inverter to keep the 12-volt battery topped up, because all of the accessories and running stuff in an electric car still runs on 12 volts for compatibility with all the parts supplier. But typically that DC to DC converter is about 1 kW, like it is in the Prius and some of the smaller electric cars. Turns out in a Chevy Volt, I just found out that it's a 2 kW DC to DC converter. So I can draw 2 kW out of the 12-volt system on a continuous basis, and that will all come through this DC to DC converter from the high voltage battery system in the electric car.
Bob,
yeah, go ahead.
So I'm not completely following you. So when you were up on the top of that tower, are you saying that you had the car running for 4 hours and you had that whole contraption hooked up to bring you power? Is that?
Yeah, and one guy, he's demonstrated he's run his Prius for a week like that. Because remember, a hybrid will just sit there not drawing any power really until it needs power. And so as I draw power out of the 12-volt battery, whenever the car thinks it needs it, it'll power up the gas engine and replenish the 12-volt battery. So the car will just take care of itself. And like I said, some people have left it running for a whole week to provide backup power.
On one tank of gas?
Yeah, one guy did it. I might be confusing my numbers, but he demonstrated a week's worth of power from his hybrid. Because again, theoretically, he would go to sleep at night, the loads would go down, and although the car is still out there in the on condition, the engine's not running, and there's only about 100 watts of phantom load, to keep the system alive. So anyway, some people will say, well, I can do that in my gas car. I can just leave it in idle. And no, that's not the same at all, because even with a 60 amp alternator, with the car running at idle, you'll probably get about 30 amps average. And at 12 volts, that's only about 400 watts. So you can't, and nobody would want to leave, and that's the point you're making, the gas car just sitting out there running for hours or days at a time. So this applies to hybrids because they will start and stop the engine as needed to maintain the electrical system. And so EVs can power homes during blackouts. And in fact, in Japan, it's a standard module that you can buy with your Nissan Leaf or your Toyota, and that is the whole house interface, so that when the grid goes down, and remember they had the Fukushima nuclear disaster, when the grid goes down, you can backfeed your house for as long as, if it's a hybrid, as long as you got gas in the tank. And if it's a regular EV without the hybrid backup, then it's however many kilowatt hours of capacity that battery has.
I followed that for a while. Wasn't that whole house car to whole house trial terminated? That was unsuccessful and they discontinued it.
I haven't heard that at all. I thought those things were still available. They don't sell them in the United States, so I just really haven't paid any attention to it. But anyway, what I'm showing you in this talk is that anybody with a hybrid electric vehicle has that capacity to use their car as their emergency backup system. And believe it or not, you just do it at the 12-volt level so that anybody can do it with big monster jumper clips. And you don't have to get in and start hacking away at the electronics of your electric vehicle. That would be ideal, and that will come. In fact, since this is the year of the electric pickup truck, every electric pickup truck, of course, is going to have inverter built in to provide you thousands of watts of electrical power, for the worker. So anyway, electric vehicles can power homes during a blackout. And this is an example of the satellite view on the left before the disaster. And even during the disaster, the point is there's still pockets of lights that where people still have power. And so even though the grid is down, EVs don't, where's my picture? EVs don't wait in long gas lines. And when the fuel runs out and the pumps go down and everything else, because an EV can always go just look around the neighborhood to where they see the lights are on and go ask to plug in for a charge. So again, most people aren't aware because again, it's just not on their radar. But that EVs are now better, cleaner, faster, quieter, safer, cheaper to buy, cheaper to operate, and cheaper to maintain than the average gas car when you consider some of the incentives that are out there. And my energy reawakening began in 2007, when that was before you could buy an electric car, but hackers were buying, I buy salvage Priuses that had a little bit of body damage, and I beat the body damage out with a hammer and then turned it into an EV. And you've heard all the excuses of why EVs are not applicable. But if you pull a string on almost every one of them, it's wrong or it's 10 years old. And remember, we've had electric cars now as a matter of routine for 10 years. So a lot of what you hear about electric cars is outdated. Most of our energy is spent driving locally. And now I don't know why these two slides got in here, but I've been trying to donate an electric charging station to the ARRL so that when somebody with an electric car visits, they can plug in and top off. And the typical cost of plugging in for say a 2-hour visit is 50 cents worth of electricity, and good for about 20 miles of added range. I also think the ARRL should definitely go with solar power. They spend $8,000 per month on electricity, and that's our membership dues are paying that bill. And there's just no reason for that when with solar and the return on investment could be getting our power for half of that amount. But like any other bureaucracy, they've got enough other problems that they're worrying about, so that they don't. It's just never on their radar. So anyway, here is the picture of the. There are now 62 electric vehicles on the market. Half cost less than the average gas car, and half now have ranges over 350 miles. A lot of people, are concerned about range. So I sorted those 62 cars. And this is just the front page. The second page is double the number of cars. Anyhow, 50% of those cars have ranges greater than 350 miles. So that's, in fact, the Toyota Prius Prime plug-in has over 640 miles of gas range, and it only has 25 miles of electric range. But my daughter has one, my wife has one, and almost every single day they go out and drive and come home, and they haven't burned a bit of gas.
Bob, can you speak to lithium batteries and recycling them once they're through?
So far, we're not even to the point of recycling them, because so far, with over, 20 billion passenger miles of electric vehicles over the last 10 years, not a single battery has failed due to wear out. Now, there have been plenty of batteries that have failed simply because things fail. But all electric cars come with a 100,000 mile, 8-year warranty. And so like any new car, there are failures, but all of those battery failures, if there are any, occur under warranty and has not been a problem. The primary place where the lithium car batteries will be recycled is fixed storage, energy storage, backup for the grid, because a battery that's lost 20% of its capacity is generally the standard, where people say, okay, that's no longer useful for transportation, but still, it's still a big, huge battery that has 80% of the original capacity. And if it's just going to sit there 99% of the time on standby, that's an ideal use of the batteries. Eventually, you're going to get to the point where, yeah, chemically, the entire battery will be recycled. And I think they figure that 98% of the materials in such a battery are recyclable. Here's the thing. A typical car in America is on the road for 18 years before it's finally totally scrapped, if it makes it that far. It might go through multiple users, but from the day it was bought until it's finally scrapped to scrap metal is typically 18 years. And so you need to think carefully about, when you buy a new gas car and put it on the road today, what's going to be happening over the next 18 years. So here's the back to this one slide. This slide is the front half of this handout that's published by the local electric car club, and that is 25 of these full-size electric cars are battery electric vehicles, and they're always pushing the range higher. And now the typical range is over 230 miles or so, and all the way up to 300 mile range. And then the flip side of this are the plug-in hybrids, and 32 of those are plug-in hybrids, which means they have the gas engine and the battery. And that's what the Chevy Volt is, and I just absolutely love it because I get 50 miles of daily range. And if I go any further, the gas engine just kicks in and it works just like a normal hybrid. And finally, 2020 is here, and this was supposed to be the year of that we were going to start seeing all the electric pickup trucks, but a lot of that's been delayed because of COVID. And so one or two of them are available by the end of this year. But the Ford F-150, am I saying that right? Electric will be out next year, as well as the Chevy and so forth. And of course, it's inevitable because electric cars only have one moving part. And so, and the cost to operate is about 1/3 to 1/2 the cost of gas. And so it's just inevitable that the market will, people will be buying electric cars. But the thing is it's a totally different paradigm shift, because electricity, a battery is not a tank. A tank is something you fill up once a week and you do all your stuff till you get near empty, and then you refill. Whereas an electric vehicle is something that basically you leave it plugged in except when you're using it. And so every time you get in the car, it's fully charged. You start every day with a full range, and it's charged while parked. And you got to remember, okay, I got a slide coming up. Anyway, one thing is when you see somebody plugged into a gas pump, you think about a $40 to $50 transaction. And so when you see somebody plugged into an extension cord, plugged into an outlet, you think of similar costs. No, it's about 20 cents an hour. And if you stay plugged in for a 10-hour overnight charge, that's about $1. Am I doing this right? 10 hour, yeah. About $2 a day for the full range of that car. And every EV can charge from any 120 volt outlet, because every single EV, whether it's a Tesla or Chevy Volt or Bolt or whatever, comes with its own 120 volt charge cord shown there on the left. And so you don't need an $8,000 installation of electric vehicle charging station. You just plug it into an outlet. And if you're willing to charge overnight, again, you can do that from a standard 120 volt outlet. This is the charging pyramid that shows that we've always anticipated that most of the charging is going to be residential, plugged in at home. Some will be at the workplace if there are outlets in the garage, and there will be some charging in public. But the need along the interstates is for high speed, rapid, high voltage charging. And that's where all the focus is, all the news reports and all the stuff about high speed and charging in 20 minutes and all this kind of stuff. And yet that's only 1/3 of 1% of the need. And so a lot of people spend too much time worrying about this interface charging. Generally, we used to say, if you're a road warrior who's always traveling, an electric car is not for you. An electric car is mostly for local travel. And if you're going to be on the road all the time, drive a gas car. But now with most of the current production of electric cars having 250 to 300-mile range, it is now practical to drive for 300 miles, take a coffee break, and spend 20 to 30 minutes charging, and then get back on the road. So this slide says it all, and this is the 24 hours a day of 7 days a week, and it shows where are the cars. And the green is the time that the car is at home. The red is the time that it's parked at work. The blue is the time that it's running around doing commercial errands. And the very tip top blue line is where you're driving. And the reason people focus so much on the time to charge is because they're used to the 5-minute fill up in a gas car. But the thing they don't realize is that's the ultimate in inconvenience, because the only time you can do that is when you're using the car and you're out and you're on your way somewhere and you got to stop and pull over and get gas, because that's the only time you can refuel. Whereas if you have an electric car, you have 21 hours a day that the car is parked somewhere. And if you can plug into a 120 volt outlet while you're parked, that's up to 100 miles a day you can get just from a standard 120 volt outlet. So the concept is electric cars are charged while they're not in use. Gas cars are refueled while they are in use. So this idea of public charging is kind of like a security thing, like having a spare gas can. And every place that there's an outdoor outlet, I try to encourage people to put up a charging sign, because there's an asset there that somebody can use. And the charging load at 120 volts is simply 12 amps, the same as a coffee pot. And so you can, the load on any circuit of adding one more coffee pot is not significant. Another nice thing is if you charge overnight from 120 volts, that'll give you a 40-mile range. But if you can also plug in while you're parked at work, you just doubled your range to 80 miles a day, and that's quite a lot of range, since the American average is 40. Going renewable, this slide shows kind of what I did starting in 2007, when I realized it's a whole new world of energy, and it shows how I eventually changed from over energy equivalent of 3,000 gallons of fossil fuel per year down to virtually nothing. And the total energy bill now is about $8 a month from BG&E, just to have an account. Let's put that into dollars. Basically, my family, we live in an old leaky house that only has 2 inches of insulation in the walls. Our annual energy bill was about $6,000 per year. Most of that was home heating oil in a 80-year-old fossil fuel boiler, and then there was the electricity, incandescent lights, and of course gasoline for the cars. And the total energy cost was about $6,000 per year. After going solar and switching to LEDs and driving electric vehicles and switching from oil to a heat pump, that's down to only about $300 a year. So again, my solar reawakening began in 2010 when I started looking at grid tie. And of course, solar has gone down by leaps and bounds. And even by 2015 was less than half the cost of the utility. The price of solar panels went down from about $15,000 down to about $1,500. This is one of my solar arrays. And like I said, the cost went down almost 10 to 1 over the last decade. And so what is grid tie solar? Grid tie solar simply says you take all these 30-volt solar panels and you hook them in series, and that gives you a supply voltage of about, anywhere from 300 to 550 volts in series at about, 8 amps. And that's what, just 2 wires, that's what goes into your grid tie inverter. The reason you hook them in series is to save copper. So you bump up the voltage and the current stays the same. So you can use number 12 or even number 14 house wiring for your solar distribution. That goes to the inverter. The output of the inverter is simply line 1, line 2, neutral and ground, which go to a 20 amp breaker in your distribution panel, no different than any other breaker. And that's where the backfeeding occurs. There is a requirement for an external disconnect. It's on the wall of my garage. So again, the power company can flip the breaker and disconnect your system if they need to. So those are the essentials of a grid tie net meter account. Now, if you wanted to go off grid, you're going to spend at least 3 times as much. And so it's uneconomical in the first place. And your wiring now has gone up by an order of magnitude in cost, because now everything is in parallel to stay around 48 volts. And when you have, when your array is 100 feet, 200 feet from the house, and you're trying to push 48 amps from the solar array up to the house, that's a heck of a lot of copper. So anyway, where am I going? The number one, and so where does the cost come in? Yeah, there's the cost of copper, then there's the cost of the batteries, and the batteries only last about 5 years. You can argue that with lithium, they last a lot longer, but it's that replacement of the batteries over time that is what is the cost factor. But the other factor is that you get twice as much power during the summer when you usually don't need it as much, and you get half as much power in the winter when the sun angle is low and when you think you do need it. And there's no way to save that excess power from the summer to use during the winter. But all that goes away with grid tie, because during the summer you've been pushing your meter backwards and you're gaining kilowatt hours, and then in the winter you can use those kilowatt hours anytime during the year. So what I'm trying to tell you is the value of the home battery, there is no economical value to the home battery now, but it will be in the future. In fact, it's absolutely a part of the whole system, because energy storage is the number one issue with solar. And so I keep talking about the cost of batteries, and you also asking, why am I talking so much about electric cars? Because there's your battery. You get this huge, huge battery manufactured, the economy of scale. And that's what has driven the price of batteries down by a factor of 10 to 1. And so it's this perfect marriage of the need of solar to have big battery storage, and the fact that electric vehicles are now here that have huge batteries, and they actually come for free because you're going to be using that for driving your car. But in the meantime, it could be used as your solar energy system. But the problem is that if you're using that as a whole house backup, I'd like to have power when the grid goes down in the middle of winter, you're really only going to use that a couple of hours, or maybe one day is when the grid goes down. All the rest of the time, this huge investment that you've made in this huge battery is accomplishing nothing. But here's where it's headed. This is called the duck's back curve. And you see that it's the number of megawatts over time during the day. And so overnight, it's kind of a base load. And then if you look at the line at the top, it says traditional, then the load would start increasing in the morning and would get up to a maximum about midday as everybody is at work. And we all know that the peak cost of electric power is the peak is during the day when everybody is using it for work and everything else. And so you have this huge demand in the middle of the day, and that's when the peak demand charges apply. However, as more and more solar gets added, when are we producing solar? We're producing that during the day. By 2013 in California, there was so much solar online that there was no longer any peak electrical load. It was almost constant because the solar filled in for all the added load. And then by somewhere in there, they noticed that, hey, we're starting to get to the point where there's an overgeneration risk. There's more solar being produced than we could possibly use. And in fact, if you look at the chart at the bottom, yeah, on some days in California, the price actually goes negative and they have to pay people to use electricity to be able to use all of that electricity. And that is where the solar battery at home is going to just pay dividends, because at the point where the utility will pay you that 5 to 10 to 1 variance in electricity value, then the battery will pay for itself in just 2 years. So you ended up with basically a free whole house battery because you were using it for load leveling. And you can see here, that's another advantage, is it's only for the 2 or 3 hours in the afternoon from the time that the solar starts to shut down and the people come home and the commercial load starts to go down. It's during that time from about 4 to 6 to 7 p.m. when the demand on the grid is huge. And the grid operators are paying 10 times the cost of electricity to meet that demand. And that's where, when they start paying the homeowner for the value of that electricity at a 10 to 1 rate, you can see that it doesn't take very long at all for the battery to pay for itself. So don't go out and buy a whole house battery for 2 reasons. Number one, you can buy a used electric car and get a battery 3 times as big at half the cost. And number 2, wait until the grid and the utility company will actually pay you for the electricity that's in it. So anyway, separate your mind that grid solar power does not equal emergency power. Grid power is economical power, half the cost of the utility. And remember, if you're talking about emergency power, you're only talking about 1 day a year or a couple of hours a year. And the value of the electricity that you're trying to reproduce is only a dollar or so. And so don't spend $10,000 for a battery to provide, a dollar or so worth of electricity without, thinking about it. Make sure you know what you're doing. Now, in the past, when I first started giving this talk, you still had the problem when the grid went down, you still didn't have access to your solar array. Well, now for the last several years, if you buy the Sunny Boy brand of grid tie inverter, then it comes with a standard 15 amp outlet, 120 volts. And as long as there's sunshine, you have power on that circuit. And so you can use that circuit for grid down electric power without even having a battery. Here's back to what they have in Japan, where you can do battery, car to home power. But as I've said, you can do that with just a plug-in inverter or a $150 inverter from Walmart clipped to your battery. And that can provide, during grid down conditions, where you don't have every light in the house on and you don't have absolutely everything turned on, you can easily draw that from the 12-volt system. Now let me make a short diversion, because remember I said I wanted to tie this all into the fact that everything is high voltage DC. And so what's ideal, instead of wiring all of your panels in series up to say 450 to 500 volts, put a tap in the middle so that you can actually arrange those panels during grid down conditions to be 2 arrays of panels in parallel. And so now you've got 15 amps at 300 volts. And as I've said before, almost everything with universal power supplies now can run on that kind of DC. How do you wire up switches at high voltage DC and high current? You can spend up to $300 for a high voltage DC switch that is UL approved. Very expensive. Or what I do is I use just a $6 AC, air conditioner disconnect box from Home Depot with a pullout, because these things are rated at 60 amps. They're rated at 600 volts. They're not rated for DC, but as you know, if you pull that disconnect out, you'll draw an arc, but at least the arc will extinguish. And that's the thing about DC switches, why they're so expensive. A high voltage DC, remember, is impossible to interrupt because all it will do is form an arc, and the arc will burn until everything around it is burned down, including your house. So that's why DC disconnect switches are very expensive, because there has to be a quenching system to quench that arc. As I've noted here, I use the pullout as a method of doing that. Anyway, so now you got 300 volts DC that you can power everything that's modern and universal in your house, except for the stuff you actually need. So I spent all this time talking about the viability of high voltage DC, but what you still need is high power 60 hertz AC for the really critical appliances in your house. And so that's where we're still waiting for that car battery to 60 hertz inverter, which should cost only a couple of $100, for the electronics. It's just that the market demand is not there yet. But once people start buying these electric pickup trucks and realizing they can plug their whole house into the bed of their pickup truck, they might start demanding that these be in every electric car. But of course, everybody still wants to have some kind of battery backup. So you need to calculate what you need. It turns out the refrigerator only draws 100 watts. It's amazing, but I finally got around to measuring it. Although the nameplate data will say 800 to 1,000 watts, remember that has to include the amperage for the strip heaters that come on for defrosting. And during grid down, power out conditions, you really don't need defrosting. Of course, the defroster is going to kick on automatically. It's going to trip your 1,000 watt inverter, but as soon as it trips, you just cycle the power on that inverter and you just keep operating, and the refrigerator will not try to do a defrost cycle for another 8 days or whatever it is. So anyway, calculate what you need. Oh, and with the use of LED bulbs, it used to be that the 55 bulbs in our house with all the kids at home, that could be 5,500 watts, almost 5 kW for lighting. Now that's only 500 watts. And so you take 500 watts for every light in the house, 100 watts or two for the TV and internet, and 100 watts for the refrigerator. And you can draw all that power you need from the 12-volt battery in your hybrid or your electric vehicle. Now, I do have to mention that if you operate HF or ever have any intention of operating HF, beware of solar RFI. It is horrendous. K1KP's article in QST, April 2016, showed what he had to do to, the noise floor went up by 25 dB whenever the sun was shining. And so he had to take every single panel down, run twisted, replace all the wiring with twisted wire, have chokes everywhere, and still the noise is just barely tolerable. So I'm telling you that even if you yourself are not going to go solar and you have HF, then you need to be proactive and get out there in your neighborhood and talk to your neighbors, because once your neighbor goes solar, and the first time you hear about it is the day you turn on your HF rig and find out that you've lost 25 dB of noise floor, it's too late. You're never going to be able to sue that guy enough to get your HF spectrum back. So if nothing else from this talk tonight, if you value HF, there's only one of 3 types of solar systems that's bad, and it's so bad it's terrible. Anyhow, do your prior planning to make sure you get an RF quiet solar system for your own house. But even more important is make sure that nobody within a block of you is going to go solar. And if so, please talk to them in advance and make sure they don't buy that bad system that will kill your hobby for the rest of your life. This is a little bit on environment. There are 7 billion people now that are sharing all the air and the water on Earth. And if you put all those into a sphere, this is what you get. The sphere at the top is all the air on Earth grabbed into a single sphere. And the typical American house uses about 4 tons of coal per year. And that's an awful lot of coal. And of course, the devastation of the planet from mining coal is one thing, from refining oil is another. But fortunately, lithium, there's a 10,000 kilometer square lake down in Bolivia, I guess, where again, all you do is you bulldoze up all that salt into piles and then take it on a truck over to the refinery and refine the lithium, and it's a much cleaner system. I can't emphasize enough the importance of understanding this slide. It's from the Department of Energy. On the left are all the sources of energy in the United States. On the right, in pink boxes, is all the uses of that energy. And of course, when we use energy, there are 2 things. We get useful work, which is the gray box called energy services, and we get all the wasted heat, which is shown as rejected energy in the larger gray box up there. And you'll notice that over on the left-hand side, the boxes at the top are all the renewable energies, and then the ones, the bottom half are all of the fossil fuel sources. There's natural gas, coal, biomass, and petroleum. Those are all the things we burn to generate energy. The interesting thing is you'll notice that all of those that burn in order to get energy do it by producing heat, and 2/3 of that is what doesn't do anything for us. It's just a rejected energy or wasted energy. And only about 1/3 of it is actually doing what we needed to have done. The other thing to notice at this chart is that coal is now has reduced by 20% or more just in the last several years. And so now it's no longer the number one. In fact, it's the number 3 producer of emissions. And now what's left is the number 1 emission source in the United States is petroleum. And where does all that petroleum go? If you start on the left and you follow it to the right, yeah, some of it goes up to industrial, but the vast majority of it goes into transportation. And of what goes into transportation, the big green chunk on the left, over about 80% of that is the wasted heat that blows away from our radiators in the car. And the very small gray thing at the bottom is what's actually used to propel the car. And so now when you compare, let's see, my next slide should do that. Yeah, let me catch up. So there on the upper left is all the renewable sources of energy, all the fossil fuel sources of energy, all the rejected energy that is wasted as heat, almost all of it coming from fossil fuels that have to be burned into heat to get the energy in the first place. But then if we look down here where I was finishing up, that small gray box down there, or small gray bar, is what actually provides the transportation in the United States. And notice that that is no bigger than the source of the renewables over on the left-hand side. So if you rearrange that chart, already today, we have enough renewable energy to provide all of our transportation without burning any oil at all. So anyway, we're there. We just need to change our mindset. And that's why I talk about electric vehicles. So the point, one of the things about this talk is I'm not saying just go out and just change your whole lifestyle, but be prepared. Think about what's going to happen the next time your water heater breaks. Get a heat pump water heater and save more than a half, save almost a factor of 3 on the cost of heating water. Yeah. And the next time your air conditioner or your HVAC goes out, consider switching to a heat pump, which again will save you at least half on utility costs. I'd said it before, and that is that you can have transportation forever at the American average 40 miles a day with just 12 solar panels worth of energy. Of course, you can sign up for wind power in all the states that offer deregulation. Almost everybody has switched to LED lighting by now, except for those people who have found that they produce so much RFI that really wipes out HF. So when you go LED in your house, make sure to test the brand of bulbs you buy to make sure you're not getting an RFI source. Go electric on all small engines. It's just unbelievable. Well, this is mostly from a pollution standpoint, and that is the amount of toxic emissions from a gasoline-powered lawnmower during 1 hour's operation on the weekend is equivalent to 11 days of commuting in a modern gas car. And the reason is since the 1970s, catalytic converters are required in all of our transportation systems, but all the small engines, motors are still out there with no catalytic converter, and are still adding just as much pollution as we had back in the 70s. Anyhow, the next step is to consider a plug-in car for your next vehicle. And if you're using either the 2 most expensive sources of energy for heating, and that is propane and fuel oil, considering cutting your costs in half by switching to a heat pump. And as the point being that these days you don't have to do a wholesale replacement of to add a heat pump in your house, new ductwork and everything else. You can buy window air conditioning heat pump units you can buy these portable units in the lower center here that just have two hoses that go to a window, and that can be an air conditioner, a heat pump unit combined, or the mini splits in the lower right-hand corner are just unbelievably the way to add heat pumps in any room in the house. And all you have to do is 2 holes the size of your thumbs to connect the indoor unit to the outdoor unit. And if you're using, like I said, heating oil or propane, you can reduce the cost of heat in that room by a factor of 2. And then lastly, do not even consider running an electric water heater anymore when you can replace it when it's needed with a heat pump water heater, which is nothing but the same water heater, but it has a heat pump unit at the top, just like, the guts out of a refrigerator. And that'll save you half on the energy cost for heating water. Back to these mini split heat pumps, you can put them almost anywhere. And what I tell people is, again, all this talk is to be prepared for the next major energy decision you have to make. And that is, whenever your AC fails, don't replace the AC unit, replace the AC unit with a bidirectional heat pump, which only costs about 10% more. And it's the same hardware. It's just that it has a reversing valve so that it can do heat as well as cooling. It cools, it dehumidifies, it heats, and it'll really save money. In fact, these mini split heat pumps, because now they all use variable speed motors. In order to get variable speed motor, what's the first thing they do is they full wave rectify the incoming AC line to DC, and then they can use variable speed DC to DC converter to control the speed. And because you're starting off with high voltage DC, you can put together however many solar panels you want to provide and just tap right into that DC point, and you can run the HVAC heat pump air conditioner unit on solar directly. So there's nothing certain in life except death and taxes and utilities, and you can do something about the utilities going solar. Now, here's a point that a lot of people say, well, my orientation is not south. It turns out if your house is pointed 45 degrees off of due south, you really only lose 5%. If you're pointed due east or west, you only lose 15%. Of course, if you're off grid and you have to have power for the worst winter day, if you have an east-facing array, you're going to be down almost 50%. And that's what people think. They think that they don't have good solar potential unless they have south-facing. And the point is, with grid tie, you don't have to have south-facing, because the only thing that counts with grid tie is the total power produced during the year. And there is a point during the year, i.e. in the fall and in the spring, when the southeast and southwest facing house will actually produce more because the sun rises in the northeast and sets in the northwest, and the south facing array is not even taking advantage of that morning and afternoon sun. So the point is don't worry about orientation. You don't see anybody putting up those erector set grids on the roof of their house to point their solar panels south anymore, because you just don't need that. You just put the solar panels wherever the roof is facing, as long as it's not north. And there is a time during the year when you'll still be producing 85% or more of the total annual power. So direction is less important. And in fact, because of that, if you have an east-facing roof, that also means you have a west-facing roof, and you can actually generate 170% of what the ideal south roof can produce, because you have now twice as much roof area. And that's the limitation that a lot of people have. So again, don't even worry at all about orientation. What's important is there sun there at least 6 hours a day? Now, the next thing is tilt angle. Again, you don't see any erector set type structures anymore, because to get exactly the ideal sun angle, because during the year, what matters is total production. And you can show that the panels can be anywhere from 20 degrees to 50 degrees, and the difference is only 1%. And so at my church, we lowered the array to, instead of being 40 degrees, which is what it should be in this area, we lowered it to 25 degrees, we still were within 1% of the total energy production, but the array is not so much sticking up in your face as it would be. So again, tilt angle doesn't matter that much either. The biggest problem for solar is shade, but it's also the easiest thing to fix with a chainsaw. And just getting rid of a single tree, let's put it this way, a 6 kW array on the roof of your house reduces carbon as much as 200 trees, or almost 2 acres of trees. So although it's painful to cut down a good shade tree, at least you have the option of cutting down that tree and gaining a huge environmental advantage by replacing your carbon with solar electricity, and then plant a new tree exactly where you want it. So anyway, the whole point is that solar really saves on carbon and is equivalent. Each solar panel is equivalent to 8 mature trees as far as carbon reduction. Okay, lastly, remember, a solar investment is not a cost. It's an investment for life with more than 10% annual rate of return on that investment for the rest of your life. I challenge you anywhere to find a guaranteed 10% rate of return from any other investment. Now, here's where I've been giving this talk to groups now for almost 10 years. And so I think it was, the Anne Arundel Radio Club. I was giving that talk one time and I said, okay, did any of you here go solar based on my talk? And one guy raised his hand, and everybody else, I pointed out that, do you realize since I last gave this talk, and if you have a $100 a month electric bill, you have thrown away $11,000 to the utility and you have nothing to show for it. You missed out on the $3,000 worth of tax credits, and you missed out on over $2,000 of local benefits. So your cost for doing nothing was $15,000 compared to the guy sitting next to you who took that same money, invested it in solar, and is quite happy about it. Now, this slide is the slide I want you to take away. That's why I have the big gold box around it. And let me explain this. What is the value of $12,000 in retirement savings, or just in savings in your bank, when you have a $100 per month electric bill? You're going to have that $100 per month electric bill for the rest of your life, unless you go to senior living or whatever. Then it'll change a little bit. But you've got $12,000 in savings, and you've got $100 a month electric bill. That's $1,200 a year in utility bills. At the end of 10 years, you are going to have gained $1,200 in interest, but you will have spent all of your equity. All $12,000 in savings is gone because you had to use that to pay your electric bill. All right, so you got 1 year worth of earned interest to really give you 11 years. So that $12,000 worth of savings and having a $100 a month electric bill gave you electricity for 11 years, and all your savings are gone. Now, on the right-hand side, if you take that same $12,000 and you buy a 6 kW solar array, which cost $16,000, but remember, as soon as you pay your taxes that year, you're going to get $4,000 back immediately. So basically, your net cost was $12,000. You're going to get back over $600 a year in solar renewable energy credits, and that's kind of a black art, but you know, that's money that the state or utility will pay you because you've joined you're contributing to the grid. You're going to get $1,200 free electricity per year, and you're going to get $1,000 or so, you know, other potential benefits. And so at the end of 10 years, or even from day one, you have $16,000 worth of equity that you own on the roof of your house. Nobody can take away from you, and it's yours. So at the end of 10 years, you have that system value. You have the tax refund, the $5,000 tax refund. You have the $3,000 of solar renewable energy credits. So basically, you have $20,000 worth of equity. You avoided $12,000 in electric bills. You own your own energy system. the net value to you is $32,000 at that point after 10 years, and you have no utilities for life. So which guy would you rather be? The guy who ends up after 10 years with nothing, having spent all his savings on the electric bill, or having invested that in solar and retained all that equity and value. So anyway, the point is there's just nothing better than solar if you have sun on your roof or on a spot in your yard for at least 6 hours a day. And we're going to be wrapping up here. Then the only other question is are you going to pay for it, or are you going to let somebody else pay for it, which means, rent it. There's all these companies that'll come out, put it on the roof of your house at no cost, and all you do is you start paying them instead of the utility company, and they guarantee that you will pay them less than what you would have paid the utility, but it'll only be about 10% less. And so who's making the money there? It's that leasing company that use their money to put their solar system on your house, and they get all the advantage. So it's always best to use your own money, either via a loan or from savings, to invest in that solar. Oh, and of course, always get 3 estimates. They'll be all over the map, and so don't go just with the first guy that waltzes through your front door with a great deal. Now, a lot of people say, "Well, I'm waiting. I hear that there's more efficient solar panels out there, and I'm waiting for." They just went up another 2%, at Diamond Labs or something. That is all smoke. Well, it's not smoke and mirrors. Yes, higher efficiency cells are always just around the corner, because the space industry will pay anything for just another fraction of a watt, whereas the homeowner will not pay another dime. And so the cost of silicon solar has done nothing but go down by 2 orders of magnitude, to where it started out at $100 a watt and is now down to about 30 cents a watt. And that's what, home silicon solar panels are. Whereas the high efficiency cells have done nothing but go up, and they will do nothing but go up, because the Lockheed Martins and the space industry will pay anything to get that one more watt. And last year's model, which is not quite as efficient, is just completely abandoned. There's nobody that's going to invest in that last year's 1% less efficient cell, when the Lockheed Martins will pay anything to get the higher thing. So right now, then, like I say, the high efficiency cells cost 1,000 times more, and all you get by that is a factor of 2. They produce about twice the energy per watt, but you got to pay 1,000 times more for that. So saying you're waiting for new technology is just a waste. And then people say, well, the impact on the grid, the grid can't handle it. Well, we saw that in Texas, there was a problem, but it was not the renewables. It was the fact that 2/3 of the fossil fuel sources shut down. So anyway, by 2015, many countries had already hit 100% solar and wind, and their grids did not go down, because we know this is coming. And all they had to do was just change their procedures and predict, solar and wind. And so the grid can handle it. There's one other do-it-yourself tip. You can double your grid tie inverter power if you have, in my case, all of my best solar was to the southeast. And so that's my first array that I put up. But what I noticed is after the shade of the morning falls on those panels, I get a sunny spot that opens up in the afternoon in the back of the house. And so I put up another whole set of solar panels, but I get to use the same inverters, because the front inverters, solar panels, are not producing. And so I can just wire those panels in parallel and get double my system without having to buy additional inverters. And let me make my recommendation here, and that is, you cannot do it yourself solar, because you've got to have all the permits, inspections, certifications, and everything else in order to tie into the grid. And the only economical solar power in bulk is to be grid tied. So here's the trick. If you're a do-it-yourself person, and most hams are, is you contract with a local solar provider to provide the smallest system that he will install. You know, he would love to install the biggest possible system he can sell you. But you tell him that, oh, I only want to put my toe in the water. I only want a small 2 kW system. And at that, the going price for a contractor install system is $2.50 per watt. And so a 2 kW system, which is really only 8 panels, would cost you $5,000. You go ahead and do it, sign the contract, get that contractor to install your modest or very small 2 kW system when you might really need a 10 kW system. But you get a 2 kW system, but you get the inspections and the certifications and the building permits and the licensed electrician. You get all of that stuff. And once the system is signed off and you get your net meter, you will never see the electric company again. And now you have a net meter, which means any excess power that you generate on your property, you can just plug it into a standard outlet and your meter will go backwards and you get full credit for it. And you can add your own panels for 1/5 the contractor cost. The cost of solar panels these days is about 30 to 50 cents per watt. Remember that, 30 to 50 cents per watt is the cost of the solar panel, whereas the contractor provided is $2.50 per watt. But you've got to go through the contractor to make it all legal and to get the net meter. And from then on, whatever you can do to generate power is up to you. Remember, the national electric grid stops at the outlet. So whatever you plug into the outlet, even if it's only one of these $150 grid tie inverters from China, you can backfeed that completely legally. So anyway, I think pretty well worn you out. The idea being, as you see, it keeps going on and on. The idea being that solar is economical power, unbelievably economical, half the cost of the utility. But the only way to do it at any value, more than 1 or 2 panels, is to go grid tie. And the only way to go grid tie is you've got to go with a contractor. But once you've got that grid tie net meter, you're able to plug in additional sources of power from the roof of your RV or from the roof of your van or from wherever, and take advantage of those solar panels the other 364 days of the year when you're not using them at field day. With that, I think I'll shut up and see how many questions have piled up.